All right, lesson 4, page 3. We're going to divide radicals with the same indexes. The radicands of radicals can be divided if their indexes are the same. When dividing, you can reduce the factors outside the radical, the numerical coefficients, and the factors inside the radical, or the radicands. Make sure to simplify after dividing. So you may need the quotient rule of radicals. So when the index m is the same, you can reduce a fraction that way. So it just depends on the situation, okay? So look at the first example. There's no way to reduce a 1 and a 64, so go back this way by separating them into the same indexes, okay? So the square root of 1 over the square root of 64. That way you can do the square root of 1 is 1, the square root of 64 is 8. So that is one way to do it. But let's say you have 8 over 18. You can reduce them, divide by 2, and you're going to get the 4 over 9. The 4 over 9 is then 4 over 9 that way under the radical sign. That's what's going to get you the 2 over 3. All right, so being familiar with this going back and forth is a good way to use this. Let's say that doesn't spring to mind, okay? Let's say you didn't want to reduce it, and the first thing you did was split it like this one. So this is the same problem again, using quotient rule back the other way. Simplifying this. This is square root of 4, square root of 2, so that's 2 square root of 2, okay? 18 is the square root of 9 square root of 2, which is 3 square root of 2. So from there, you can actually reduce away the two radicals that are the same. The square root of 2 over the square root of 2 is a 1. So you can make them go away, and you're still left with this. So either way is perfectly acceptable, whichever one springs to mind while you're working on the problem. Okay? So it's good to know both of these rules here. This way and go back that way. Whatever you need to do what you need to do. Okay? So look at the next one. You're given the radicals apart from each other. So you can simplify 180 is 36 times 5. So that's 6. And then take the 2 and 1x. So that's this reduced, or simplified, excuse me. This gets simplified to that. Then you reduce. Let me, making a mess of it again. Hang on. So 2x is on top, 1x underneath, leaves you 1x on top. Leave the 6 there, and then these reduce away. So that's your final answer. But let's say you choose to put them together under the same index. Because they're both the index of 2, okay, you can put them under the same index and reduce them here. 5 goes into 180. If you recognize that, you can put them together like this. 5 goes into 180 36 times. And then you have x to the 5th minus 3. It gives you x squared. And then that's a perfect square of 6x. So either way, perfectly acceptable to use these rules, okay? So I may do them the same way as you or not. If it springs to mind both ways, I'll try to put both down here. But so for this one here, square root of 16, square root of 2. So this is going to be 4 square root of 2 over square root of 2, which is 4, right? Or convert that to 32 over 2, which equals 16, which equals 4. Either way, okay? This is already given me this way. So this 225 ends in a 5, so you know it's divisible by 5. So that's going to reduce to 45. if I did that right. Let me check my calculator. 225 divided by 5. Yep, 45. All right, and then x to the 17th minus 4 is x to the 13th. So this can be changed to 45x13. Get this out of the way. Okay. 45 has a 9 in it. 13, let's see, that was a 2 because there's no number there. 13, that goes 6 times because that's 12 with one remainder. So that is x to the 6x. And you can put that all together and get 3x to the 6, 5x. You can separate it if you want to take the time to do that. I think this worked well, though. This one, I think I'm going to choose to put together. So, how do I know the 293 is divisible by, 294 is divisible by 3? Remember the divisibility rule for 3, 2 plus 9 plus 4, 11, 15. 15 is divisible by 3, therefore 294 is divisible by 3. So you might as well put it together. That might be easier than finding the biggest perfect square in there. And then you have P5 over P6. So I think I'd do that way because 294 divided by 3 is 98. And then 5 minus 6. I don't think that 6 is supposed to be there. Oh, that's a typo because we're not into negative exponents yet. So actually, sorry, on your paper there's no 6 there. That makes life easier, doesn't it? Sorry about that. Okay, so that makes that clearly a 4. That's a lot easier. All right, so 98 is 2 49s. So, and P4 is 2. So my final answer is 7P2 square root of 2. All right, so that was a typo. I will fix that. Sorry, writing it down so I don't forget. Cannot find my pencil. Sorry, hang on just a second. Sorry. Okay. And then some more practice down here with both of them. I would take and reduce the 5 out of both of these. That would give me 4 and 3 if you reduce by 5. Okay. And then the cubed root of 108. Wait, let me double check. 108 divided by 27 is 4. Yep. Can't read that. Sorry, having problems with my pencil here. And is that going to help me? You know what? What if we... Sorry. Getting very messy here. Ah! Okay. Sorry about that. 15. You know what? Let's I'm trying to see the best way to show you. Let's go with 5 times 3. This is 5 times 4. The 108 is the cubed root of 27 times the cube times the cubed root of 2 times the cubed root of 2, because 4 times 27 is 108. So I can do that. And this is going to be cubed root of 2. So that goes away, that goes away. And the cubed root of 27 is 3. So 3 times 3 is 9 over 4. And this cubed root of 2 is left. I bet there's 5 different ways to do that problem. That's just one way I'm sort of picking to do it. Okay? However you get through that. Sometimes it's easier to separate things into factors. All right, how about foiling? 2 times 7 is 14. 5 times 2 is 10. 2 times negative 8 is negative 16. 5 times 7 is 35. Negative 21, 12, positive 24, 42. All right, so there are a lot of terms going on there. Can any of those be simplified? 10 can't be. That's 2 and 5. 35 is 5 and 7, so that can't be. 12 can be. So that's negative 42, 3. How about the 42? 42 is 6 and 7, so no. 6 is a 2 and a 3 and a 7, nope. So that would be my final answer. I don't even have room to write that guy. 14 square root of 10 minus 16 square root of 35. None of those can be simplified, so that would be my final answer on that. Yeah, it looks weird, doesn't it? I think we're good. Maybe there's no reason to simplify that, but I wouldn't take chances. I would simplify it just to make sure. But I'm sure the other ones don't simplify, so we're good. All right, let's try that one here. 220, 10, 2, 4, 10, plus 20. 20 is 4 and 5, so 2 and 5, which is 4 and 5. Goodness. Plus 10 and 2, plus 4 and 10, plus 20. Well, that one doesn't have anything that combines either. Alrighty. Let's see. Because this is a multiplication, I can't do anything with them individually to simplify them, so what we're allowed to do, because they have the same index, is 27 times 9, and then times x squared times x, 3. So 27 times 9 is 243, which is a perfect fifth. And this is going to be 2 plus 3, which is 5. Don't multiply those. You're multiplying the bases. When you multiply the same bases, you're adding the exponents. So you get there. 243 is a perfect fifth of 3 is the root there. And then that's 1, so that's that. Oh, that's kind of tricky. So that's the final answer of that one. Okay.